Hello, I'm an old guy and I do maths. And the topic of conversation today is, what is differentiation all about? Well, first of all, congratulations. You've got to the point in high school or college or university where you're getting into calculus and mathematics. And that's a step that not everybody gets to take. And differentiation is usually where you start this. So let's not concentrate on the process. There are other videos in this playlist that show you how to differentiate and how you can differentiate specific things like um, logs or whatever. There's a whole series of them. What we're concentrating on today is why you do this, what you're going after, and what you're going after is a thing called a rate of change. That's one thing, or maybe a maximum, or a minimum. These are the main things that you're going after. Now, there is I know that there's a video in the channel on rates of change, but I'll just talk about those briefly. So let's just assume that we have some sort of a quadratic. It's more fun with quadratics. You can do this with a linear equation, but it's really boring. And let's just say, in fact, we'll be able to explain a couple of these things with this diagram. Let's just say that you want to know what the gradient of the line of this quadratic is at this point. What differentiation allows you to do is to find the rate of change or the gradient. These are the same things. The gradient of a function is the same as the rate of change of that function at this point, or this point, or this point, or sometimes most importantly this point. And coincidentally, this point is the minimum value of this function. Now, that's easy to find with quadratics, but consider this. Here's a cubic, and this brings us to our third point. This is the minimum of point of this cubic, what's called a local minimum, because the cubic goes on forever, presumably. But it's a local minimum. It is the point at which the rate of change of this is zero. The gradient is zero. It's not positive, it's not negative. And the same is true of here, which is a maximum, a local maximum. And what differentiation allows you to do is it allows you to work out what these points are. It also allows you to work out the rate of change at this point, or any point on this graph. Now, there's another area related to maximum and minimum, and I'm just going to draw a rough artist's impression of a box. So I want you to imagine that this doesn't have a top on it. It's a box, and it's got measurements x, y, and z, and for instance, the volume of this box is a function of x, y, and z. Now, you can use differentiation to work out what the optimum values of x, y, and z are, usually expressed in one term, x. But you can use differentiation to work out what the optimum values of these are to give you the greatest amount of volume. That's a maximum. Now, volume is expressed as a function. Volume is equal to something cubed. We'll just call it x. And we can use the differential of this to find the maximum potential value of these that give us, or rather the values of these that give us the maximum potential volume. Now that's really what it is that you're looking for with straight out differentiation, the sort of stuff that you do see in high school. There are other things that it can do. It can do all sorts of things. But this is where you start. Once you know what you're looking for, this becomes more understandable. Now, there are videos about maximum and minimums, about finding gradients, and there's a video in the playlist that examines this idea, how it is that you work out using differentiation the ideal values of these three lengths to give you the maximum value of, say, the volume of a box. Okay, that's a rough explanation of what differentiation is all about. It's actually an explanation of what differentiation is about to start with. There is more. There's lots more to it. It's a big wide field, but you have to start somewhere. So thank you very much for watching. I hope that this proved a useful little guide. See you next time. Bye.